So the objective of this presentation is to define what a megacity is in terms of how the CTBUH looks at it, and then compare that to the data that we collect on tall buildings and the data that's been collected by other reputable parties in terms of the quality of life in those cities, population density, and the like. So first things first, what is a megacity? We define it as an urban agglomeration with a total population of 10 million people or greater, consisting of a continuous built-up area that encompasses one or more city centers and suburban areas economically and functionally linked to those centers. Now that's kind of a mouthful, so I'll take you through a couple of examples to show why we've arrived at this decision and how comprehensive the definition actually is. But I'll give you a few figures first. Based on that definition, there are almost 1 billion people living in megacities. That's 13% of the global population. The total combined area, of course, is quite small, 0.66 of the globe. And the number of 200-meter buildings, it has roughly just over half of those that are 200 meters or taller are located in these cities of 10 million or more. A megacity essentially is polycentric, whereas perhaps earlier forms of cities were not. The ancient city could be thought of as a boiled egg. Basically, you have the center, the yellow part, is like where the people live and where the king lives, theoretically, and then you have a defensive wall around the outside. The idea was basically to keep intruders out and to some degree subjects in. As we moved into the industrial and Enlightenment era, cities became more fluid, and so you had the center and a defined periphery, but no defensive walls to prevent passage from one way to the other. There were economic disincentives, of course, to live in one place or the other, and you certainly saw separation of workplace and residence. Now, in the modern city, we have what's more like a scrambled egg, really, where it's polycentric, it's kind of amorphous, it's connective, but it still tastes pretty good. Basically, you have an interdependent city that supports a mix of uses. It does, however, make that city somewhat confusing. For example, a megacity is connected but not always cohesive. This is an aerial shot of the Los Angeles megacity. That red line is the edge of the political boundaries that include Los Angeles megacity. The culprit there is actually Riverside County, which extends all the way from the eastern edge of the urbanized area to the Colorado River and the border with Arizona. Obviously, most of that is open desert, but we include it because politically, the decisions that are made in Riverside County as a jurisdiction affect what goes on both in that open desert and in the highly urbanized areas. To the same extent, again using Los Angeles as an example, you've also got mountains and unpopulated areas in the middle of urbanized areas. The overall area of this megacity is larger than Austria, and it's approximately equal in size to that of Serbia. So the focus of our conference, of course, is going to be the world's biggest megacity, the Pearl River Delta. We have almost 65 million people here. It typifies the megacity condition in several ways. It's polycentric, it's economically interdependent, but it does have culturally distinct areas. Obviously, the two most obvious outliers are Hong Kong and Macau, which are special administrative regions of China, but have very distinct cultures and customs. But actually, I think you could say the same of Guangzhou versus Huizhou. It's just not as obvious to people who live outside the area. Nevertheless, it is very much an interdependent economic zone, and I think we're going to try to prove it with our hop-on, hop-off bus tour that we're conducting of the three cities. So again, about the same as Croatia, interestingly enough, but it has 15 times the population of Croatia and more than double its GDP per capita. It also has the greatest number of tall buildings, 200 meters or higher, of any city in the world, but it's also only the 23rd densest megacity in the study, which seems really hard to believe when you think about places like Hong Kong, which actually contains some of the densest places in the world, upwards of 30,000 people per square kilometer. But that's just Hong Kong. The whole area that's encompassing Pearl River Delta includes mountain ranges and some areas that are frankly quite suburban in character. Okay, so here's some more facts about it. As you can see, in terms of area, it's relatively compact, but the GDP is way off the scale. It's roughly between Australia and South Korea, if it was considered as a country. The per capita is not quite as high, and I think that reflects actually the mix of economic uses that are in this area. Historically speaking, Shenzhen was the industrial town, Hong Kong was the center of finance, and Guangzhou is a little bit of a combination of the two. But I think you're starting to see that meld together, and hopefully we will start to see that GDP per capita go up. But of course, that's going to be dependent on what happens with the population and the population density. So, where are megacities? Predominantly, you're going to find them, not surprising probably to anyone in this room, in Asia. So, 10 of them are in China alone, 29 are in Asia. And what's interesting about this is, here's a close-up actually. You can see the giant orange dot with 64,899,778. That is PRD. The 40 million plus one over there is Tokyo, or no, sorry, that's Beijing, Tianjin, and then to the right, the 42.797 is Tokyo. So here's how it breaks down on a global scale. Of the world's 45 megacities, 64% are located in Asia. We have another 11% in Europe, and then it breaks down from there. There are no megacities in Australia or Antarctica. The percentage of global population that lives in a megacity, though, is still relatively small. It's not quite as impressive a figure as this repeated figure that you will hear about urbanization overall. Remember, we're specifically looking at megacities with a total population of 10 million or more. Nevertheless, 1 in 5 Chinese lives in a megacity, which also should not come as a surprise. Now, here's what's interesting. In some ways, China is the most typical, but it's also very atypical because, China has converted in a massive way from being a relatively poor country with an industrial economy to a services-oriented market capitalist economy, lifting millions of people out of poverty in the process. But that's not necessarily true of where most of the rest of the megacities are located. So by 2010, we're going to see an urban population, well, we already have seen an urban population of 3.5 billion, 2.6 billion of which lived in developing countries. In 2050, the figures will be 7.3, 5.2, and 83% respectively. So another way of putting that is the urban population of developing countries will grow 15 times as much as developed countries. And this is what a developing country looks like. This is a picture of Dhaka, Bangladesh, typifying the situation. More than 1.5 billion of Asia's 4 billion people live within 100 kilometers of the Indian or the Pacific Oceans, where rising sea levels could overwhelm existing coastal barriers, and I would say in some cases already have. And this is a look at the quality of life indexes. The HDI is the Human Development Index maintained by the World Bank. And I've chosen to show those that are in the medium or low category by country. So you see how many of these megacities are actually located in areas that have severe problems with quality of life, be it poverty, access to healthcare, jobs, sanitation. So a lot of the megacities are not necessarily going to be these glittering, spire-laced cities like what we see here, but something a little bit more like this. This is Karachi, Pakistan. This is actually the densest megacity in our study. And to look at it, you would never guess that. It has exactly one tall building taller than 200 meters, and that's not a picture of it. We couldn't find a picture of it. I mean, we have very little data about this town other than it has a lack of tall buildings. So the only way of densification is clearly not to go ever upwards. Of course, the quality of life is another story. You have 147 in the country HDI rank. I think that's out of a total of about 180. Jakarta, Indonesia is probably a little more typical of the transition that we're seeing. In the front, you see a lot of very crowded low-rise housing. It's a coastal city. It's on an alluvial plain. It's expanding a lot horizontally. It's quite large, 6,438 square kilometers at the moment. Relatively high density, above 4,000 per square kilometer. That makes it the number 2 city in our study. But it has 46 tall buildings of 200 meters or greater. And you've got a fast developing skyline. The story with Jakarta, and I think this is going to be the story of the developing world in general, is that the tall buildings are going up, but the infrastructure is not necessarily keeping up with it. Right, so this is Dhaka once again. No buildings over 200 meters. Extreme density, also, of course, extreme poverty and human misery. Mumbai is kind of a bipolar example. Again, you have a lot of tall buildings going up here. You actually have some extreme wealth, and of course you have extreme poverty. I think it epitomizes the megacities of the global south, where you have expanding wealth against a backdrop of persistent slum conditions. And this is really how most megacities are actually growing. It's very informal. There's very little access to services, infrastructure, sanitation. This is another interesting way of looking at it. It sort of illustrates why China is such an outlier, but that you have to pay attention to because it's so massive. The way that China is growing has actually caused the de-densification of many of its cities. So the change in average density of people per square kilometer in China overall as a country from 2000 to 2010 is 78 per square kilometer. Compare that to Indonesia, 1,974. So Indonesia has become massively more dense in that same time period. And actually, if you look at some of the more advanced countries in Asia, which are doubtless very dense, South Korea, is down 73. Taiwan, if separated from China, is down 519. So if you separate out all countries, it's 321. That is 321 more people on average per square kilometer during that 10-year period. Excluding China, it's 864. And there's quite a few urban areas in China with decreasing density, yet they are gaining more tall buildings. So the equation that doesn't necessarily compute with intuition is we're getting denser, we're not necessarily getting more tall buildings, and then in other places, we're getting more tall buildings, but we're not necessarily getting denser. So this kind of puts that into context. This, of course, is an aerial view of Hong Kong, one of the densest places on Earth. And I think this is, when you say megacity, this is kind of what you picture. You picture the sparkling metropolis of the future, analogous to the visions of Hugh Ferris or Fritz Lang from the 1920s. But, this is how most megacities are actually growing in the developed world or developing world. I would say in the tier 1 and 2, it's largely housing blocks like this, separated by big roads, not much thought being given to the interstitial space, and the urbanized area grows, but the actual density is declining. This is, of course, a shot of Los Angeles. I was actually just there last week, and I was on top of the U.S. Bank Tower, and yes, I did take the sky slide. I'm not sure if it's worth $13, but I did get to observe actually a much clearer day than when this photograph was taken, and it indeed is sprawling. What's kind of interesting about Los Angeles, though, is that it's a lot of single-family homes very close to each other. So I think there's hope for it. I think that people are already accustomed to living very close to each other, and I do think it will continue to densify in that polycentric fashion that I've illustrated. But again, this is most of the world. Okay, so now where are these tall buildings and how do they fit into the megacity picture? This is the number of tall buildings of 200 meters plus per megacity. You can see that New York and Philadelphia is a big outlier there, as well as the Pearl River Delta. I believe those are number 1 and 2, and those are followed relatively closely by Jakarta, and it looks like the Beijing-Tianjin couplet is actually number 3. About 55% of 200-meter plus buildings are located in megacities. So this is, again, a sort of illustration of where it's not exactly a negative correlation, but it's not a terribly strong correlation either between the size of the megacity, the combined population of that megacity, and the number of tall buildings contained within it. You would expect everything to kind of just follow the curve, like the Pearl River Delta, okay, biggest, has the most tall buildings, but after that it kind of breaks down. And the same is kind of true on the global picture. New York, Philadelphia being somewhat of an outlier. Okay, so I'm going to show you a chart that is actually reproduced in the copy of the journal that you should have in your delegate bags. This is kind of a key that will explain what all these silhouettes and these bubbles mean. So the idea is that each building silhouette represents the shape of the tallest building in a selected megacity that we're focusing on. Its architectural height is shown in the upper left. The black fill indicates the percentage of 200-meter plus buildings completed so far in that city, and the white space shows what's still left to complete. And then the people figures represent the density of that city, 250 people per square kilometer per figure. So now these silhouettes only show the 28 megacities that are included in the study, which have at least one 200-meter plus building. There are 45 megacities total. So ranked in order of density, you can see that the densest megacities are not necessarily the ones with the most tall building construction, though in some cases there is a strong correlation. Some of the other research presented at this conference, including that which was the subject of our seed funding this year, delves into this in more detail, but it's sufficient to say that factors other than pure supply and demand are probably at work here. Istanbul and Mumbai, for example, still have a long way to go in terms of completing the buildings that are already on the drawing board. Depending on how many of these hold residential space and for what demographics, that might impact their density numbers positively. You know, it's remarkable to think that the Pearl River Delta has 220 buildings of 200 meters plus, and only 64% of them have been completed so far. So we still have almost 40% left to complete. And, you know, it's common to hear critics of skyscrapers to speak admirably of a certain type of density. You know, a density that you could perhaps best epitomize by Paris. You know, walkable streets, buildings of a human scale, lots of people living close together, but good access to services, etc. And who could argue with that? I mean, everyone loves Paris, but can every place be Paris? I don't know that it can. That's why we're looking for the kind of innovation that you're seeing displayed in the keynote presentation, as well as everything that you're going to see following. So here's the megacity with the third highest number of 200 meter plus buildings is actually New York and Philadelphia, which should be on a different slide. There it is. It's in the lower third of densities. Okay, so that's partly because the vast suburban landscape of New Jersey lies in between New York and Philadelphia. The entire state of New Jersey is actually included in our measurement of this conurbation. Even Nagoya in Japan is less dense than this. The amount of skyscraper construction that still remains to be done for us in a city like Shenyang might be enough to meaningfully alter its density figures, assuming that the city boundaries don't also expand, which is a strong possibility, or that most of the buildings that do get constructed are not densely occupied. So that's going to make a big difference. So what are the implications of 13% of the world's population living in megacities? Well, having illustrated that most of them are coastal, let's consider just two in China. The one we're sitting in, Pearl River Delta, and the one that a lot of us came here from today, Shanghai, account for 80% of the exports of China, even though it's less than 25% of the population. So if we had to move one of these cities, or even react in a dramatic way to rising floodwaters, we have a lot of work ahead of us. So here's some directions that work can take to start future-proofing our megacities. The world is an increasingly interdependent place. We know only too well from revelations about greenhouse gases, climate change, rapid spread of viruses, whether you're talking about biological or technical. The choices we make in one part of the world have a huge effect in the other part. So nowhere is this more the case than when we're talking about pieces of critical infrastructure that are set in the world's megacities. Today, the world of urban planning and infrastructure is mostly a 2D, horizontal proposition, mostly in the public domain. But it needs to become a 3D world that's fully integrated with the vertical city, which is largely in private hands. So, this drawing might look fanciful, but the technology to achieve what you're looking at here already exists. But whether we have the willpower to overcome long-standing political and organizational barriers, the kinds that are increasingly becoming meaningless in the global megacities, is a bigger question. So these are some built examples from around the world, some of which you've already seen in Munsum Wang's presentation, that show how megacities could grow. Tall buildings and cities almost become one and the same. We have to start thinking of tall buildings as infrastructure in themselves, which carries broader responsibilities to the community, just as we need to expand our concept of planning from the sort of 2D thinking that we have now to include this critical third vertical dimension. There won't be one template that can be copied around the world to solve all these problems, but that does not mean that we should not think big. This is a community that has no difficulty thinking big. The big thinking, however, in my view, needs to extend beyond the height and the style of individual buildings and to instead think in terms of systems. That's tall buildings being part of a three-dimensional, globally connected, and locally vital infrastructure. Those who finance, design, and operate tall buildings and decide where they should be built need to think big in this sense if we are going to be part of the solution. Thanks. Thank you.